Example Basics03Beat shows how to use a beat, a reoccurring event over time. Because next to just simply playing notes to create musical patterns, of course, the rhythm and the reoccurring beat plays quite a big role in music making. So the library Wellen also supplies some mechanisms for allowing the creation of beats. So we start the sketch with an import of the library, and then also again opening a window with the old school 640 by 480, and then we have a setup method and also a draw function. And this is so I do this like every time I start a sketch. I just put in all these standard things. So the first thing you should know about, or you need to know about beat, is that you need to start it actually. This is best be done in the setup method if you want the beat to be playing and throughout the entire sketch. And this is done by just writing beat.start and then supplying the start function or method with a reference to the sketch itself. However, it could also be another object of another class, but for now we roll with this sketch, so that's why we use this. And then a beats per minute, a number that defines the beats per minute. Beats per minute means actually quarter notes per minute in music lingo. Effectively, you can think of this as a minute has 60 seconds, so this would be 120 beats per minute would be like 2 beats per second. So this actually means that every beat happens every half second. Okay, so 2 beats happen in 1 second, so half a second per beat. This, you can actually change this number quite a lot. You can also do something like 480, yeah, that's 4 times 120. So instead of every having 2 beats per second, you then have suddenly 8 beats per second. If you need quicker, faster beat, and so on. But more about this later. So once we started this, the beat, then we have a, it will run in the background until you pause or stop it. But how do we actually get notified of the event of a beat, of the occurrence of a beat? For that, there's a callback method, which you would also need to write. It works somehow similar to these built-in processing callbacks. Ours is called beat, and it's necessary to also write this integer into the method call. And we can actually name it anything we want, but it needs to be an integer, but it can be called anything. I call it beat count because that's what it actually does. It's a number, an increasing number that gives me the number of beats that have occurred since we started the beat. So it starts with 0, and then after a minute it's approximately 120, and so on. So the first thing we can do now is to do something in this function that's then now supposed to be called every half second. So maybe the first thing we can do is to really just play a note to see if everything works. So I'm just going to use some semi-random values. So we have like 48 is the pitch and 100 is the velocity, and then we just run it and let's see what happens. So save the sketch first and then let's go. Let's go. Okay, you can hear kind of that it is playing, but you can hear a little bit the beat happening. Again, like it's because we're not turning off the note. It plays forever. So in contrast to the actual example, I'm just gonna add a third value to the note so that it actually turns off after an eighth of a second. So let's see this. So you can hear it playing. Deet, 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 deet. And this is, I keep saying it's approximately half a second because the timing in Java is really not perfect. So it can be off actually a little bit. So you can assume that it's half a second, but it's really plus minus a few microseconds or whatever. So we can now maybe have a look at the beat counter, because we can also use that to our advantage to play some notes. So what I've done in that other example here, I'm just going to reproduce this. I create an array with a few notes in it, and maybe I'm just using the exact same one from the actual example. So this would be C3 maybe, and then what else did I use? C4. So this is the octave. And then I'm just going to duplicate them and change them slightly. So I have 4 notes now in here. So I can get my note from that array by using the beat counter. So the first time it picks this note, the second time the beat is called, it picks this note, the third time it picks this note, the fourth time this note, and the fifth time it would crash the application, because it would then just try to pick a note that's not in the array anymore. And to constrain this beat counter, this ever increasing beat counter integer, to constrain it to the size of the array, meaning that it would always count from 0, 1, 2, 3, 0, 1, 2, 3, instead of exceeding the bounds. There's like a really nice hack, or not hack, but really nice shorthand of constraining this counter, and it's this modulo, and then using the length of the array, which in our case is actually 4. So, so if you use this, then it will never exceed the bounds of the array, and that's really handy for now. So, so now we would have a like we would pick one of the nodes from the array. It would always go through all 4 of them and then repeat this, and then it would play those notes. So that's here. So we can hear the notes playing, and yeah, maybe I'll just a little bit lazy, just copy these 2 methods again from the actual example. Here I'm using the I'm actually using a second variable, beat count, to make the current or the last triggered beat, or the last triggered beat, actually to also save it, to make it also available in our function here. And what I'm actually doing is, like, I'm using the modulo again, which is again like especially in combination with beats, it's a very nice technique to use this modulo. And what this one actually does, it's if you don't know what modulo does, read up on it. It's somehow magic, although very simple. What it actually is, it's a remainder of a division. So I divide my number by 2, and if there's some remainder, that is what I'll have as a result. So if I divide something by 2, yeah, if it's an even number, the remainder is 0. So 0 times would be nothing, plus 0.225. That would be my scale, 0.25. But if beat counter is an odd number, the remainder is 1. So 1 times 0.25 plus 0.25 would be 0.5. So this the scales actually will be alternating between 0.25 and 0.5, and then therefore scale our ellipse according to these two values. And again, like, it's really magic, because otherwise you would need to have like an if sentence or statement or something else. But with this modulo, you can create these reoccurring patterns. Yeah. So if modulo 2 really just jumps between 0, 1, 0, 1, 0, 1, as long as you give it like an integer number here. So for example, a modulo of 3 would alternate between 0, 1, 2, 0, 1, 2, 0, 1, 2, and that can be used actually quite nicely in combination with the beat to create like reoccurring patterns. More on that later, actually, as an algorithmic composition technique. So if we play this now, right? Or if, I don't know why I wrote the example like this, but if we, for example, now alternate between, or count, or receive values between 0, 1, 2, 3, yeah, you know, because I'm using the 4 here, 0, 1, 2, 3, 0, 1, 2, 3, then we would actually get like a different scale for every somehow that actually works better with the example. Maybe I change it later. Okay, but this is the way in which you can actually create these time-based structures that we are expecting so much when we talk and think about music. And again, maybe as a quick demonstration, now I'm increasing the beats per minute by 4 to 480. So and it will just run faster. Oh, also interesting, it creates some hiccups or artifacts. It doesn't play all the notes anymore, and that is probably, I guess that is probably due to the this automatic triggering of the note off event, because that apparently that is challenged by the speed of the beat, the occurrence of the beat. Yeah. So apparently the note off doesn't happen quickly enough. So either we decrease that note off duration, or we decrease the beats per minute again. But you saw visually you saw the gist. That, I think, concludes this example about time-based structures. Okay.